All right, guys, are there any questions over any of the assignments thus far? Any questions over any of the assignments we've done so far? Now, what we're looking at today is showing that two triangles are similar by angle-angle similarity. Angle-angle similarity. Two angles of one triangle are congruent to two angles of another triangle. Then the two triangles are going to be similar to each other. Now, we showed when we were talking about congruency that angle, angle, angle did not work because we can make the triangle bigger or smaller, but the angles would remain the same. So what it actually tells us is that if we have two angles, or really if we have three angles that are congruent in two triangles, then they're going to be similar. They're going to be similar to each other. They're not going to be the exact same. Right, and that's when we talked about congruency, not similarity. Okay. And really, angle, angle, or angle, 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 having three or two doesn't make a big difference, because if we know two angles, we can say that this is 60 and this here is 90. Well, we know any three angles in a triangle add up to be 180. And if I know two of them, 60 and 90, we can find the third, because we can add those together and subtract from 180, and we would see that this angle here is 30. Well, if we know that these two angles are the same, well, it means that this one also has to be 30. Because if we know two angles in one triangle are congruent to two angles in the other, well, the third angles have to be congruent. And we also know that from our third angle theorem. So, if we're going to determine that two triangles are similar by angle-angle similarity, all we need to do is show or prove that two angles are congruent. Once we've proven that two angles are congruent, we can say the two triangles are similar. Now, looking at these two triangles here, we have EDC and HGK. We do see that one set of angles are congruent. And the set of angles that we have are congruent are going to be angle D is congruent to angle what? Because they are both 90. And that there would be one set of angles. So having those two congruent gives us one set of angles that we need. Now all we need is an angle. Now we need to find another angle in one of the two triangles, because they told us that angle C is 26 degrees and angle H is 64. Well, those two aren't the same. So we need to either find the angle E, the value of angle E, or the value of angle K. We need to find one of those two angles. Which one do we want to find? Okay. Well, we know that these three angles, G, H, and K, all add together to be 180. So we can add 64 and 90 together and then subtract it from 180. Well, 64 plus 90 is 154. And if we subtract 154 from 180, so we get that the measure of angle K is 26 degrees. So does that give us a second set of angles that are congruent? Yes. We can say that angle C is congruent to angle K. And E and H would be the same as well. So if we had found E, we would have saw that that's 64 degrees, which would have given us two angles. But we only need two to be able to show similarity. We don't have to put the other one because all we need are two angles. Now that we have those two angles, we're going to write a similarity statement. Now our similarity statement is going to be almost the same as our congruency statement, but instead of writing a congruency sign in the middle, we're going to use a similarity sign, which is just a single little squiggle line. Now, to start this off, we need to name one of the two triangles. So which one? So CDE. We're going to name it first. Now, when we write the similarity statement, it doesn't matter which triangle we pick first. We just need to pick one of them and give it a name using the vertices. Now, the similarity statement for the second triangle needs to follow the same pattern as the first. So we started off with angle C, went to D, and then E. Which angle is congruent to angle C? K would start. And then G, and then H, because G and D match up. And then our last one is H. And that would be it. Questions on this here? All right. So determine whether the triangles are similar. If they are, write a similarity statement. Well, looking at these two triangles here, we do know that angle X is congruent to what? Angle R. Because X and R are both 21 degrees, yes? So we do have one angle. How many more do we need? Well, two or just one, because either way works, because we need two total, we've got one. We need one more, yes? Which angle can we find? Why? Because looking at these triangles here, we can see that T and Z are not the same. T is 61, Z is 99. So we can find Y, and we can do that by adding 99 and 21 together. Because if we add these two together and subtract from 180, we can find the other angle. So this here would be 120. And if we subtract 120 from 180, we get, so the measure of angle Y is 60. Does that match the measure of angle T? Does it match the measure of angle S? Most likely not. But if we went on and found angle S, 61 and 21, 82, and if we subtract 82 from 180, we get 98. So we do still have one set of angles that are congruent, yes? Do we have a second? So can we say these are similar? No, these are not similar, because we don't have two sets of congruent angles. Any questions on this here? Now this next one here is an interesting one. Now we do need two angles that are congruent. So I'll pick F. What angle is angle F congruent to? Any of them, so give me one. Okay. Our second set would be G and R. Really, any set of two angles I pick would work. And we know that they are all congruent because of our congruency markers in both of these here, yes? So it actually works out that all three angles are congruent for both. So they are similar. They all would be 60. Now we still need to write a congruency statement. So triangle what? FGH is similar to triangle RSQ. Could I have also said QSR? Yeah, or SQR, or any version of those three, yes? Because this one's the one that's unique, because since all three angles are the exact same, no matter how we write this statement, it's still going to be true, because any of the angles can match up to any of them. As long as I don't repeat one and say triangle RRR, that just doesn't work. That's just a point. But any way we do this one here would work. Questions on this here? All right, let's look at this one here. Write the similarity statement. Now, they did give us two triangles, CDF. So we have this triangle here. And we also have triangle DEF. Now this time, unlike the last few, they put the two triangles together next to each other, yes? Now we still need two angles to prove similarity. Angle, angle. Do we have one set of angles that are congruent? Because at this point here, we do have two angles that make a straight line, yes? One of the angles is 90, so the other has to be 90. So we can say that those two angles are congruent, yes? We would say angle what? DFE, yes. Is congruent to angle? Yes. Now, we could have had that flipped, because I could have said angle DFC first, or angle CFD, because again, we can do that in either order. But again, why did we need three letters instead of one? Right, there's two angles there, isn't there? There's more than one angle there. They have the same one, so we need three letters. Because anytime we have more than one angle at a vertex, at a vertice, we have to use three letters. And when we use the three letters, we're really just drawing the angle out. DFE, DFE. I just created the angle. And that's all we're doing with those three letters. That way we can specify which one we actually want. Well, now we need one more set of angles, yes, that are congruent. Which one do we want to try to find? The one in yellow? Okay. Now we know that these three angles add up to be 180, yes? Well, we also know that the two acute angles add up to be 90, since it is a right triangle. But we can also say 90 plus 32, which is 122. And if we subtract 122 from 180, we get 58 degrees, yes? What is 90 minus 32? Now this only works if we're working with a right triangle. Since we're given a right angle, the two acute angles will add together to be 90. So we found that that one angle is 58, yes? Well, if it wouldn't scroll. So that there would be angle what? C, D, F. And whenever we're using three letters, the vertex is always going to be the letter in the middle. Vertex will always be in the letter in the middle of our three spots, our three letters. So FDE would be 32. This angle here would be 32. Now what would be the angle that CDF is congruent to? we can say FDE, because at point E, how many angles do we have? Yeah, because here at point F, I do have this angle and this angle, yes? At D, we have this angle and this one here, yes? At E, how many angles do I have? Because I have this one here that's 58, yes? Is there any other angle attached to it? No, so we can just say E. Now, I can erase that. I have a feeling you were thinking of FED or DEF. That is correct too. Yeah, that's fine, because that's also another way to name it. We didn't have to use 3 letters since there was only one there, but using 3 letters isn't incorrect. It's actually correct also.
So if we wrote that,
Yeah. Because as long as we are naming the correct angle, we're good. Because as long as you didn't put EDF, which would be the different angle, as long as it's the right angle, I will take it. Oh. Similarity segment. So when you say triangle, what? Similar to triangle. Just use the note sheet. Kind of gave it to us. C, D, F, and D, E, F.
Will those letters always be in the right order?
Some of the times, yes. As long as C, D, F, D, E, F. And especially if they're telling us show that triangle this is similar to this triangle, they're most likely giving it to us in the correct order. But that's it. Any questions on this here? Now the last thing we're going to do is using the angle-angle similarity show that it's true. So we're still doing the same thing. We just need 2 angles that are congruent. Here, they did tell us one set of angles are congruent. Yes? So that's, we're halfway there. Well, we know that angle what? B, yes? Fortunately, we have 2 angles there. Because we do have this angle here that we want, yes? They also gave us this one here to make the straight line. Yes. So that is right. We do need B, but we just need A and E. A, B, E. Kind of just drawing that out. Yeah. That can sometimes get frustrating where we're using 1 or 3. But the other one that is 52 degrees is down here, yes? So we can say B, C, D. Now we do need a second set of angles that are congruent, yes? There is one. Why A? So let's see what triangles we're comparing here. So they said ABE. A, B, E. Yes? Oh, apparently it's just a mistake in the calligraphy pen. And the other one was what? A, C, D. Yes? What angle is contained in both? Angle A, yes? It's shared. We can say it's congruent to itself. It's shared in both triangles. Similar. And that's it for this one, because it already gave us the similarity statement. It's just wanting us to show that they are. We just need to show that two angles are congruent. Angle A is congruent to angle A. Angle ABE is congruent to angle BCD. Therefore, they're similar. And they already gave us the similarity statement. So that's all we need to do. We're almost done with the note sheets. We actually have 2 problems left. This one here, we want to show that SVR is similar to UVT. At least going to keep scrolling. We need 2 angles. So, almost. So what we're saying is that these here are congruent. These here in the middle. Now, why are those 2 congruent? Because the lines intersect, yes? And they had a special name. It does start with a V, incidentally. Because these 2 angles are vertical angles. Vertical angles. Because whenever we have 2 lines that intersect, the angles that are formed are vertical angles, and vertical angles are always congruent. Now, the second set of angles is going to be revolving around the fact that these 2 lines here are parallel. So this right here is going to tell us that these 2 are congruent, that U is congruent to S because of alternating interior angles. Because the alternating interior angles between parallel lines cut by a transversal are congruent. So it's telling us that U and S are congruent. Because we could have gone the other way around and said R and T are congruent because of alternate interior angles. And then we could have said that S and U are because of third angle theorem, or vice versa. Two sets of angles are congruent, so they are similar. Questions on this here? Last problem we're going to look at. A flagpole casts a shadow that is 50 feet long. $50-foot-long shadow. At the same time of the day, same time, a woman standing nearby who is 5 feet 4 inches casts a shadow that is 40 inches long. Triangle. Triangle, right triangle. And since they're talking about the same time of day, the angle here would be the same. So we do have 2 angles that are going to be the exact same. Now, unfortunately for this here, we can't just match it up because our units are different, yes? Now, we could convert everything over to feet, or we can convert everything over to inches. Inches, because, well, 4 inches, if we convert it to feet, well, that would be 4 over 12, which is 1/3, which tells us that she is 5.3. I can't write 3 enough times because it's repeating, it's indefinite. So it might be easier to convert everything over to inches. Well, for 50 feet, we would do 50 times 12, which would give us 600. And 5 times 12 is 60, plus 4 is, so we'd have 64 inches and 40 inches, yes? Okay. That looks nice, doesn't it? Well, if you turn the page. I do have that included for us. Now, we can set up our proportionality. So we have the height of the flagpole, x over what? Oh, let's do that. Yeah, 600. And let's see if we get the same thing if we use 64. So if we said x over 600, what would we put on top for the other one? Over 40, because that's the only other unit we haven't used. Now the first thing we would do is multiply both sides by 600. And we would do this so that the 600 and 600 would cancel. Minus x is equal to 64 over 40 times 600. So 960. And to get to feet, we would take 960, divide by 12, gives us 80. Any questions on this here? So we got 80 feet doing it this way here. Now, I'm going to erase this here, because the way we've done this, and we did this yesterday, is we said x over 64, yes, because height and height. On the other side, we used over 40, yes? Because setting it up this way, we're comparing height to height, shadow to shadow, yes? What would our first step be? To multiply both sides by? These would cancel, telling us x is equal to 600 over 40. I think it gives us 960, yes? Or 80 feet. Because what are we looking at? We're looking at a proportion, yes? So when we did it this way here, we're comparing height to height and height to height, yes? The way we did it the first time is I compared height to shadow and height to, am I still comparing the same type of proportions? Yeah. And as long as we're comparing the same proportions, we could do it either way. The way that we might run into issues is if I start comparing height to shadow and then shadow to height. Once I start mixing them, then it goes a little bit sideways. But that works as well. And that's it. And you do have enough time to actually finish this in class.